as Tommy said, I'm chairman currently of this GAZAMP group. It's a group of independent scientists, and one of the things we've been dealing with in recent years is various aspects of the marine plastics issue. So I'll refer to some of that quickly through the talk. Just going back to Lebanon, I am aware, I have spoken to the people working on the redevelopment of the Cedar site, and it is going to look fantastic when it's completed, with no more litter going in from that source. The question was, is it an emerging threat? Well, it's certainly an emerging issue. We're talking about it today, but there have been a number of, on the international stage, there have been a number of quite important initiatives in going back before this, but certainly in 2008 and 10 with a big international workshop. GAZAMP itself organised a workshop in 2010, which has been published. You can download that, looking at microplastics as a potential vector for transmitting persistent organic contaminants. And then again on the international stage, United Nations Environment Programme has taken it up in quite a big way following the Honolulu meeting, and it produced a chapter on plastic debris in its 2011 yearbook, and followed it up with a special session at last year's Global Land Ocean Conference in Jamaica, specifically on plastics and microplastics, and I was fortunate to be involved in several of those. Unsurprisingly, the research community has also reacted. This is a little graph showing, if you do a search, Google Scholar and Web of Knowledge and so forth, using the terms plastic pellets and microplastics, you'll see, as our chairman said, that this was first published data in 1970s, 1972. The term microplastics only really emerged in the reviewed publication in the about 10 years ago. But you can see that in both cases there's been an extraordinary increase in publications, and that's continuing into 2014. Well, clearly, if we want to know a bit more about microplastics, there are a number of questions. What are they? Where are they? Why are they there? When were they first detected? Should we be worried about it? So what? And what can we do about it if we should be? And I'd like to thank Francois for his excellent opening presentation on the whole general issue of plastic, because microplastics are just one part of that overall waste management plastics issue. What I won't be dealing with at all is how they're observed and sampled, and that's the subject of an excellent review paper by Hidalgo Ruiz in 2012. I'll refer you to, and also, of course, in the MSFD, the Task Team 10 report, which goes into a lot of detail on methodologies. Well, microplastics are generally thought of as being primary or secondary in origin, and there's this operational definition. There's a lot of debate. I suspect it's still going to return to whether we just have micro and macro, or whether we have meso in the middle. An engineer gets very upset when you say it's less than 5 millimeters, because to an engineer, it's a millimeter and below. Ecologists think it's something else. People in the public think it's something else. So there's it's a bit of a curious definition, but that's more or less what we're using at the moment. Primary, they start off as particles when they go into the environment, generally two sources. One is the pellets, which are used in plastics manufacture and transport. The industry has actually got quite a lot better at dealing with this, because it's a waste, and it's a health hazard in factories, and it's also cost them money. So there are actually some cleanup programs going on, but originally an awful lot of material was being lost in transshipment of different polymers. The other type are plastic particles, which are used for a whole variety of industrial and domestic purposes. So industrial, to blast ships, for example, to get rid of rust, and for making molds, but also in more and more in recent years, more and more has been used in domestic products. These, not that I use them often, but these facial cleansers, but also in your toothpaste and all sorts of things like that. And they're replacing things which used to be there, like ground up almond nuts and things like that. The second source is we call secondary. They're fragmented, so it's everything. It doesn't take you very long. The top photograph is a picture of the contents of my kitchen at the weekend. It doesn't take me very long to find lots of plastic items in your house. But it's everything that's out there. It's fishing gear, it's balloons people let off, it's fabrics, it's all the things that Francois showed you. They get into the environment, deliberately or accidentally, and then there's this process of fragmentation, particularly under UV sunlight, where it breaks up into smaller and smaller pieces, but it still retains the same properties of plastics as it did before. It's just a lot smaller. Of course, large items and small items then get transported and really globally. So where are they? They're everywhere. The little stars there indicate from beaches, water column, and inside organisms. These are from studies published in the early 70s, in 1972 and 74. There were studies showing that this was that there were plastic particles out there. They weren't called microplastics. They were called polystyrene spherules, polythene cylinders, bits of plastic. So you won't find them if you do a search like that on a Google search. But even then, there was reference to uptake of PCBs and potential effects. There's a reference to blockage, physical blockage of fish guts for small fish. So the message was out there over 40 years ago, and it's just that we didn't pay much attention to it. We've seen some of these images before. This is another compilation from which Francois showed you, but in a slightly different format. There are now some quite big data compilations being released. There's one which came out just a few weeks ago from the same group, Law for the Pacific. The best data sets there are. But even with those data sets, they're actually quite limited in terms of space and time when you look at the global picture and look at certain regions. And one of the things that GAZAMP's trying to be organize is to get together some of these big data holders, these data providers, who themselves are going through these exercises of trying to collate information together and put it together so we can end up with some maps of both macro and micro plastics distributions, and they'll be made available through a digital portal being developed by UNESCO, IOC, the Intergovernmental Oceanographic Commission, sometime later this year. So that's one of the things we're trying to do. But to fill in the gaps, it's quite useful to use models. One of the earlier models was by a group with Maximenko, based in Hawaii. He looked at an ocean circulation model based on drifter tracks. And if you start off and you completely seed the surface of the ocean with particles uniformly, and let the model work, after a year you start to see some concentrations. And after 10 years, you get this quite distinct pattern. What you're seeing is the result of this large ocean circulation, these ocean gyres, the 5 gyres often referred to. The Pacific garbage patch is you can see there. And the arrow points to the med, which looks empty, because everything that's in the med's apparently gone out. Clearly, this is not realistic, but it's useful in a way. What it doesn't do is take any account of the sources going in. Now, we don't know what the sources are in terms of quantifying them, but we can get some ideas as to where they're coming from. So another group by a guy called Lord Bresson, who we're also working with, got this idea: if you started putting some proxy indicators of things like shipping density, that's a map of shipping density, and clearly the Mediterranean is a very high incidence of transshipments as well as local shipping. If you look at coastal population density, which is producing a lot of waste, if you look at the areas of impervious urban catchment, that gives you an indication of runoff. So when And I'm as guilty as anybody else. I walked here today through the impervious catchment of Athens and saw a plastic bottle lying on the floor and failed to pick it up because I was talking to someone. So I'm guilty, right? But that is an indication of where the sources are. And when you start doing that and put them in the same sort of model, you get a similar pattern, but it's subtly different. You don't get these big concentrations in the southern oceans because the sources aren't there. You don't get the same high population sources. And if you can just about make out there, you start to see a concentration in the Mediterranean, and that's reflection of the sources of higher population and shipment in the Mediterranean. Now, this is imperfect. It doesn't include fisheries. It doesn't include aquaculture. It's very, very coarse, but it's a first assumption which you can then go out and test and collect data. And if you break that down into these large marine ecosystems, I'm afraid the Mediterranean is just dealt with one large marine ecosystem, which is a bit strange, but there we are. I hope that is self-evident from there, but you'll see distribution by counts on the left side, distribution by mass on the right side, top to a micro, and bottom to a macro. And you see that the Mediterranean is a hot spot in terms of numbers of microplastics, using this model, and also a hot spot in terms of mass of macro debris. So, and then when you start looking at some of the data which people like Francois and others are beginning to come up with, it is not surprising. And I think this is a model. This type of approach is something which could be developed even further to give you a clue as to where to look. Now, one of the things we do know about microplastics is they absorb contaminants. It's been known for some time. One of the best programs that's, I think, tried to show that globally is this international Pellet Watch run out of Tokyo University, where people are encouraged to pick up these resin pellets, these primary resin pellets from the beach, send them to Shiki Takada in Tokyo, where he analyzes them for a range of organic pollutants. These are POPs in the classical sense, which are defined under the Stockholm Convention, but it's also other compounds which are called persistent bioaccumulating and toxic under European regulations. So a range of compounds, many of these have stopped being used or use is much reduced, but they're very persistent in the environment. This is a global map showing PCBs, and these sorts of maps start to show you something about the industrial history of an area, sometimes about land use. If you go onto the website, you can focus down by region. So here we have a region of Europe where you can see the data so far around the Mediterranean, including the Adriatic, and you can also focus in on regions, on countries rather. And if you go to the site, it tells you actually will tell you who in the audience here was responsible for collecting some of these data, because she's sitting here. And it will tell you when it was collected and so on and so forth. So it gives you all that metadata. So it's a really quite neat tool. And this program's ongoing, so people are encouraged to keep doing this to build up a more regional pattern for a whole range of pollutants. Now the big question, though, is whether, which Francois alluded to, is how much of this stuff is going to get into organisms. Now the thing with these compounds is they're in the environment, they're in seawater, they get taken up by organic material anyway, they get taken up by fish, especially into the lipids, into the fats, and so you'll end up with a predator which may have prey species in which have already got PCBs or other contaminants, and it may also have plastic in. So how do you tell the difference? So just having high plastic, high body burden of a contaminant doesn't mean it doesn't say that was the mechanism by which it got in there. So that's been a particularly difficult issue to deal with. But now there's some emerging evidence, and I'm going to show you one study. There have been a number of others, one of which is more recent has backed up this first study. This happens to come from deep sea fish, a deep sea bird. Deep sea bird. A bird which feeds in the open ocean. It's an indiscriminate feeder, a bit like our fulmar in the North Sea, but it's an open ocean, that's what I'm trying to say. And so this study was looking at whether a particular compound, these PBDES, flame retardants, common flame retardants, they're used as a fire retardant on textiles, and also they come in plastics to stop computers bursting into flames and so forth. So they're very useful, but they leach out. And so he did this study, and this is a bit complicated, but if you could bear with it, this is the range of different types of PBDEs that he found in the lipid of the bird on the left-hand side. These colors just mean a different cogene or a different type. It's how much bromine they have in it. And on the right-hand side, on that sort of chart, the ones at the top, the black, the gray, the blue, and the dark red, are the sort of these heavy, high brominated flame retardants. And they're the type of thing you find in plastics, whereas the others you don't. Now, the little stars above those four columns happen to be in birds with a high plastic loading. So that starts to get interesting. Then, so there's that same figure on the left. Then when you looked at the pattern, that fingerprint of PBDEs in the plastic in the stomach and in the natural prey, you get some very different patterns. So this is a really good indicator that it's PBDEs, these contaminants from the plastic, which are getting into these shear waters. And the same type of study has now been done on fish, deep sea fish, in the South Atlantic quite recently. So this is a paper published just very recently. So this is a very good indication. There's another slightly less, well, an association certainly of high levels of phthalates, which you found in plastics in fin whales from Christina Fossey's group as well, which is also indicative. So go back to the last couple of slides then. Can it be considered a growing threat? Well, yes, it can, I think clearly. And why? Well, we know microplastics are increasing in abundance, we know they get into a large number of organisms, and we know they may cause physical harm. That's all documented. The additives, which I haven't talked much about, but the additives other than PBDEs in plastics may have an ecotox effect, and the absorbed contaminants may have an ecotox effect. And there's this emerging evidence now that you are seeing this transfer from plastics into the organism. And we can't get rid of them once they're in there. So how can we get rid of it? Well, generally, the message throughout any of these conferences must be we have to improve waste management overall. We can do that in industry through the primary microplastics, but also we can look at our own behaviors. And if we do have to use skin cleansers, then we think about ways of either capturing them in the wastewater treatment, or if we can't capture them because it's impractical, then we use something else which will break down very quickly, which you can do. There's a useful little good scrub guide there I refer you to from Fauna and Flora International. For everything else, well, again, it's this public attitude. It's me next time picking up the bottle in the street, even if it's grubby and I don't know who's held it, and carrying it somewhere to put in a waste paper bin. It's reducing this other accidental loss of fishing gear and aquaculture and other materials at sea, because that does happen. And it's getting rid of stuff when it's there. So it's putting booms across rivers after a storm. It's these. Some people think that the coastal clearance, the beach clearance work is actually quite important at reducing the total number of microplastics going in. That's it. We do have a Gnite working group. It's meeting for its final session in July, looking at sources, fate, and effects. And we have to get it out and published for November because it's being presented at the Global Ocean Science Conference in Barcelona, and it's being supported by a whole host of people here, which I'd like to thank. So thank you very much.